So class today what we're going to be doing is going over the second review for the number systems test. First thing we want to realize is any base to any base. We can convert any base to base 10, and then we can convert base 10 to any base. And that's how we convert any base to any base. Now there's lots of tricks to do this for special cases, but to do any case, this is it. Because if it's base 10, we can convert base 10 to base 10 and 10 to anything. So, any to 10, which means any base to base 10. First thing we're going to do is read the directions, follow the directions. I'm going to color code this. So we have our number 536 in base 7. First thing we're going to do is space it out, which means take this 536 and write 536. And we want to leave enough space to do 3 digits underneath each one. So next thing we want to do is calculate the value of each digit, which means we're base 7. So we're thinking 7 to the 0, 7 to the 1, 7 to the 2, 7 to the 0 is 1, 7 to the 1 is 7, 7 squared is 49. Next thing we want to do is multiply the value times each number. So we're doing 6 times 1 is 6, 3 times 7 is 21, 5 times 49 is 245. 50 times 5 minus 5. Next thing we want to do is add these all up, and we get 26, 72, 672. 272, and this is base 10. I don't have to write the base 10. And answer in decimal, so we could put the 10 there, but we don't have to. So that's the answer. Next one is going base 10 to any decimal. So first things we want to do is calculate the value to each decimal. We're doing base 4, which means we go 1, 4, 4 times 4 is 16, 16 times 4 is 64, 64 times 4 is 256, and 256 times 4 is somewhere near 1,000. But realize we want to go until we hit a number bigger than that number, 272, which is 1,000 is way bigger than that. So that's where we stop. Then we see how many times the number goes into the decimal number. How many times does 256 go into 272, which is 1. So we multiply and subtract. 256 times 1 is 256. We subtract and we get. Then we ask ourselves, how many times does 64 go into 16? That's 0. How many times does 16 go into 16, which is 1? So we subtract 16 and we get 0, so the leftovers are just 0. So our answer is 10100, base 4. And realize we want to write the base 4 in orange because we're taking these numbers and writing them over there. Next one we're going to do is base 16 to 2. So we take base 16 and what we're going to do is space it out. I won definitely to BAF. So we space it out because we want to put 4 placeholders. So we go 1, 2, 3, 4. And we take that because I'm lazy, copy pasta. And then what I want to do is convert to binary. Sorry, I write 2, 4, 1. So I write 8, 4, 2, 1. So all of these are 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. And of course you can repeat this to infinity and beyond. So now what we want to do is convert to decimals. So we think how many ones are in this? So we have 0, 0, 0, 1. Then we have D. And I don't like remembering the letters, so I say A is 10, B, C is 12, and E is 14. So I can ace the hexadecimal. So D is in between C and E, so D is 13. Ace hexadecimal, ACE, 10, 12, 14, yeah. 13 is 8, plus 4 is 12, plus 1 is 13, fill in the zeros. E is 14, 8 plus 4 is 12, plus 2 is 14. F is just 1, 1, 1, 1. 2, we put the 1s, but we also have to fill in the zeros. To be or not to be 10, 10, 11, because it's 1 more than 10, 10, because A is 10, 10, 220. And F is just 1, 1, 1, 1. And now we want to remove the leading zeros, so we cross off the zeros and we rewrite it 1, 1, 1, 0, 1, 1, 1, 1, 0. And I'm right here. 1, 1, 1, 1, 0, 1, 1, 1, base 2. And that's the answer. Next one, 8 to 2. First thing you want to do is be spaced out. Next thing we want to do is put 3 placeholders. 1, 2, 3. Copy pasta. Now realize if you're weak on this or didn't space it out correctly, you could use lines, and those are imaginary lines that disappear. Next thing you want to do is write 8, 4, 2, 1. I like to go pink or go home. So I go 4, 2, 1. And you know the funny thing about this is, no one who actually sets it up like this on the test actually gets it wrong. You know why? Because no one actually sets it up like this. So then what we're going to do is convert to binary. 7 is 1, 1, 1. 2 is 1, fill in the zeros. 3 is 2 and 1, fill in the zeros. 6 is 1, 1, fill in the zeros. And 4 is 1, fill in the zeros. And then we take this and remove the leading zeros. We have no leading zeros, so it's just 1, 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 0, 0, base 2. Make sure your zeros look like zeros. And that's the answer. Next thing we're going to do is 4 to 2. Same exact thing. Let's get spaced out, man. 3, 2, 1. 1, 2, 3. Hey, that number looks cool. So we write out the placeholders. 1, 2, 1, 2, 1, 2. We write out 2, 1, which even if I'm a lazy bum, you better believe I do that. 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1. Remove the leading zeros and put it in binary. 2. Next one, 2 to 16. First thing we want to do is group into digits of 4 from right to left. So I go like this, and I go like this, and I snake it. And realize I need to add in the leading zeros. I have 3 digits, I need to make it 4. You don't have to do that, but you should. I write 8, 4, 2, 1. Convert into numbers, which means this is 8 plus 4 plus 2 plus 1, which is F. The order doesn't matter, so I'm just going to do this one, which is, what? 8 plus 2 plus 1, which is 11. So I'm just going to write 11. I know 10, 10 is 10. This is 4 plus 2 plus 1, which is 7. This is, let's go back over here, 2 plus 1, which is 3. And this is 4 plus 1, which is 5. And now I convert to hexadecimal. 5, 7, 10 is A, 11 is B. 3 is, I think 3, and F is, of course, F. And then I need to push the numbers together, which I did, and write base 16. Next one we're doing is 2 to 8. Same exact thing as the previous one. Do groups of 3. So what I like to do is be lazy. This is grouped because no line. This is grouped. This is grouped. 1, 2, 3, 1, 2, 3. Add in leading zeros. Please realize I have a group of 3. I just didn't group it, but that is a non-grouped group of 3. Go pink 4, 2, 1, and then write an octal. We have 2, 5, 7, 1, 5, 4, 6, 3. Push them together and put in an octal. Let's assume they're pushed together. Yay. Next one, 2 to 4. Please realize you don't want to just start by doing this and saying 2, 2, 3, 3, 0, because that's wrong. Because what you have to do is you have to group 2 digits together right from left. So what that means is you go 1, 0, 1, 1, 0, 1, 0, 1, and then put in the leading zeros. So you have 0, 1 is 1, 0, 1 is 1, 0, 1 is 1, 1, 1 is 3, and 1, 0 is 2. Right, base 4. I forgot to write 2, 1. Next one, octal is 8, hexadecimal is 16, binary is 2, and decimal is 10. This is the only thing you need to remember for the tricks. Reason being is 16 to 2 is 2 to the 4 to 2. How many spots do we use? 4. So what if we did 8 to 2? It's 2 to the 3rd to 2. 3 spots. The next trick to remember this, 8 to 2, if I count in binary, 1, 2, 4, 8. 8's my target. 1, 2, 3 digits. What if I were to go 9 to 3? This is 3 squared. How many digits? 2. 16 to 4. 4 squared. 2 digits. I'm not going to test you on these, obviously, because that would just be mean. But I'm just showing you the trick. X to the Y to X, where Y equals the number of spaces. X to XY. Y still equals the number of digits. 2 to 16. Which is 2 to the 4th. Which means 4 digits. So we're going from 4 digits to 1 digit. So 4 digits of binary is 1 digit of hexadecimal. Where back here, it's 1 digit of hexadecimal is 4 binary. That's the only difference. That's it. Have a good one. I will see you later.